All right, welcome to the second part of exponent rules 7.2, which is negative exponents today. So recall from a previous class, 4 to the third is 64. 4 to the negative 3 is 1 over 64. The rule with exponents is you cannot have a negative exponent be in a simplified answer. So you will be moving, the rule, actual rule is to move the base of the negative exponent and the exponent to the opposite part of the fraction. Meaning like the denominator or numerator, you switch them. So like 4 to the negative 3 is technically in a numerator right now. To make it positive, you're going to move that 4 to the negative 3 to the denominator. What that does is it's going to make it, since there's nothing left in the numerator, there's a 1 there. So it's 1 over 4 to the positive 3. Make the exponent positive. Make exponent positive. So the exponent has come positive. And then 4 to the third is 64. All right, let's take a look at number 5. We have a negative, so I'm going to look at my negative exponents and the base. So that's x to the negative 9. We also have in the denominator x to the negative 3. I'm going to take that numerator, the exponent, the base of that. Only x is being raised to the negative 9, not the 16. There'd be a parenthesis around 16x if 16 was also being raised to the negative 9. It is not. So I'm going to move that x to the negative 9 into the denominator to make it positive. I'm going to move this x to the negative 3 to the numerator to make it positive. And then the y squared is still positive, so that stays there. At this point, you now can look to simplify numerator and denominator. So we have x to the third and x to the ninth. If you want to multiply that out, it'd be like x to the third over, so I'm going to write this like separately. X to the third means x times x times x. X to the ninth, 1, 2, 3, 4, 5, 6, 7, 8, 9. Simplify, simplify, simplify. And what you're left with is x to the sixth in the denominator. So we have, the rule is with like bases, the x's are the same, you can subtract the exponents. You take the biggest, subtract the smallest, and you will place the answer where the biggest exponent started. So x to the ninth was bigger, so you have x to the sixth in the denominator. The y squared is going to stay in the denominator. In the numerator, we still can simplify some things here. 16 over 18 can be reduced. Divide numerator by 2, that'll give you 8. Divide the denominator by 2, that'll give you 9. So that's 8 over 9. And there's your final answer. All right, let's take a look at number 6. So any numerators and denominators that need to be switched, switch them. So the y to the negative 4 goes down, y to the negative 3 is going to go up, z to the negative 3 is going to go down. So you have 2x to the fourth, y to the third. That's it in the numerator. The denominator is 3x squared, y to the fourth, z to the third, times z to the fourth. Look to simplify, we have 2x to the fourth, y to the third, over, what do we have? I'm going to put these two like bases together. z to the third times z to the fourth, that's z, so we're going to add the exponents. So it's going to be z to the seventh. So 3x squared y to the fourth z to the seventh. And keep going here. We got more to do, more to simplify. I see the numerators and denominators with the same variables. So I have x to the fourth. So looking at x to the fourth and x squared. X to the fourth means x times x times x. X squared means x times x. Cross those out. Or what you're doing is you're subtracting those exponents. So you're going to be left with x squared in the numerator. So 2/3 can't be reduced. We know there's going to be 2x squared. What are we going to do with this y to the fourth and y to the third? Well, there's going to be a y left in the denominator. If you don't believe me, write it out. There'll be 3 y's in the numerator, 4 in the denominator. And you're left with 1 y in the denominator. So that's the y, or you could have subtracted your exponents. 4 minus 3 is 1, so this is y to the first. And then z, there's no other z's, so that z to the seventh stays in the denominator. There's your final answer. All right, number 7. So we're going to, what's the base of that negative exponent? The base of the negative exponent is 3m, all of it together. So we are going to take and move the base and the exponent to the denominator. Problem with this is you can't just write a fraction like that. That doesn't make any sense. There has to be something in the numerator. Well, there's a 1 there. So we're going to put a 1 here. And then we got to distribute this exponent. So it's going to be 3 squared. So 3 times 1 is 3 to the 2. And then it's m to the first. So 2 times 1 is 2. So then we have 1 over 3 squared is 9m squared. There's your final answer, simplified. All right, so that's with negative exponents. You can move them if you want right away. In this case, on number 8, there's different ways you can go about this problem. I am going to actually distribute this negative 1 in first. So I'm going to make it 2, and it's going to be 1 times negative 1. And then it's going to be x to the 4 times negative 1. And then it's y to the negative 3 times negative 1. So 2 to the negative 1. 1 times negative 1 is negative 1. X to the negative 4. 4 times negative 1 is negative 4. And that's y to the negative 3 times negative 1 is positive 3. So now at this point, now I'm going to look at what can I move, or what do I need to move. We have negative exponents and bases, negative exponents and base, so we need to move the bases. Right now this is all in the numerator. We're going to move 2 to the negative 1 to the denominator, and x to the negative 4 to the denominator. So we're going to have, it's going to end up being the y to the third is going to stay in the numerator. We're going to have 2 to the first, which is 2, and x to the fourth. That's your final answer. There's no like bases anywhere that you can simplify. Number 9, anything to the 0 power. So there's multiple ways you can do this. Anything, any base to the 0 power. Now this is a crazy base, but this is all a base that's in parentheses being raised to the 0 power. Anything to the 0 power is 1. Crazy, huh? If we didn't realize that, so that is your final answer. If you didn't realize that, you could distribute the 0 to everything. So it's 4 to the 0, negative 5 to negative 5 times 0 is 0, y to the 7 times 0 is 0, z to the first 1, z to the 0 over 12 to the 0, x to the 0, y to the 0, z to the 0. Everything's times 0. So everything is equal to 1. 1 divided by 1, that's 1. But, hey, anything raised to 0 power is 1. That's beautiful. Looking at the next problem. We have our exponents. I'm going to distribute to the negative 3. I'm going to distribute first, and then we'll worry about moving numerator and denominator. I think it's just going to be easier. So on our numerator, we have a squared, power to a power, so power to a power. So we're going to multiply, so 2 times negative 3. Then b to negative 4 times negative 3. And then we're going to distribute to the denominator, so a to the first times negative 3. I really should have these bases in parentheses. I shouldn't get so lazy. B to the negative 8 times negative 3. Let's simplify each individual numerator, or exponent. 2 times negative 3 is negative 6. Negative 4 times negative 3 is 12. 1 times negative 3 is negative 3 in the denominator. And negative 8 times negative 3, 2 negatives multiplied to a positive, 24. Now I'm going to look, I'm actually going to do this down below, much more room. I'm going to look at my negatives. So we have a to the negative 6, that needs to go down to the denominator, and we have a to the negative 3, that's going to go up to the numerator. We also have like terms, but I'm going to worry about that last. So I'm going to move this a to the negative 6 down, a to the negative 3 up. So it's going to be a to the positive 3, b to the 12th, over a to the 6th, b to the 24th. Now let's look at individual. We have 3 a's in the numerator, 6 in the denominator. 6 minus 3 is 3. And then b to 12th, 12 in the numerator, 24 in the denominator. If you simplify that down, it'd be b to the 12th. 24 minus 12 is 12. Now there's nothing left in the numerator. There's always it has to be something, so we're just going to put that 1 up in the numerator. There's your final answer. Thanks for watching.